Sir.
Yes. Today we are going to discuss this topic, finding HCF of the given numbers. Do you know, my dear children, how to find HCF of given numbers? Example, how do you find the HCF of these two numbers? How do you find?
The highest common multiple.
Not multiple, factor, highest common
Factor, sir.
not multiple. Highest common factor. How do you find? What are the methods you know? Can you tell me? Any one of you? Can you tell me?
Ma'am, sir, we will see which all like for 10 which all numbers are used to multiply, then we will find the highest factor.
Okay, can you tell me what is the HCF of these two numbers? What is the HCF of these two numbers?
16, sir.
Sir, the highest common factor of 10 is 10 itself.
What is the highest common factor?
Sir, 2.
How do you say? Which method you followed, my dear Jordan, to find HCF
Sir,
of?
I wrote all the factors, sir, and then I found the common factor.
Okay, very good, my dear Jordan. There are different methods. There are different methods. Especially, I'm going to discuss HCF of given numbers by division method. Division method. Division method. Okay. How to find HCF of given two numbers by division method, especially by using the division method. Okay. All of you listen these steps, my dear children, carefully. In these two numbers, what is the bigger number?
16.
16, sir.
What is the smaller number?
10, sir.
So we have to divide 16. We have to divide the bigger number by smaller number. How many times it goes in 16? How many times 10 goes in 16?
If you take 10 ones are 10 and do it.
10 ones are 10. Okay. 10 ones are 10. Then what is the remainder you get here?
6.
6. Okay. Is there any number to carry down here? Is there any digit to bring down?
No, ma'am.
No, sir.
No, sir.
No. So here 6 is the remainder. There is no digit to bring down. Okay. Now we have to take this remainder as a new divisor. We have to take this remainder as a new divisor. And the previous divisor, what is the previous divisor?
10.
10. We have to divide that previous divisor. We follow the same steps till you get remainder 0. We follow the same steps till you get remainder 0. Here we got, in the first step, we got remainder 6. So we make this 6 as divisor and we divide the previous divisor with this new divisor. Okay. How many times 6 goes in 10?
6 ones are 6.
Only 6 ones are 6. What is the remainder here?
4.
Is there any digit to carry down, to bring down?
No, sir.
So finally 4 is remainder. What should we do? Again, you have to make this remainder. We have to make this remainder. We have to take this remainder. We have to take this remainder as a new divisor. Then what is the previous divisor?
6.
Yes, very good. So we had to divide the previous divisor by this new divisor. How many times 4 goes in 6?
4 ones are
4 ones. Then what is the remainder here?
2.
2. Is there any digit to bring down?
No, sir.
So this is the new divisor. We had to take this remainder as new divisor. What is the previous divisor?
4, sir.
4.
Previous divisor is 4. Divide this previous divisor by the new divisor. This is new divisor. This is new divisor. This is a new divisor. How many times 2 goes in this 4? How many
2
times?
times.
Yes, 2 times. What is the remainder here?
0, sir.
In this process, in this division process, what is the last divisor?
2.
Yes, this last divisor is said to be HCF of 6, the given 2 numbers. Therefore, HCF of 10 comma 16 is 2. This is called a division method. Throughout this method, what we use here only division. Yes or no? Long
Yes, sir.
division. So this is called a division method. By division method, we can find easily the HCF of given numbers. There is another methods also there. Factorization method, prime factorization method, and factors method. I will explain you the two methods also. But out of these three methods, this is easiest method. I will explain that method also. For the same two numbers, this method is called common factors method. Okay. Here I am going to find the HCF of 10 and 16 for the same numbers. So we have to write the factors of 10, factors of 10, factors of 10, factors of 16. Can you tell me what are the factors of 10? Can you tell me what are the factors of 10? To find factors of
10
10,
ones are 10,
1 tens.
2
10
fives
to
are
the
10.
20.
Okay.
Sorry.
So 1 comma 2 comma 5 comma 10. These are the factors of 10. Now, how do you find factors of 16? One table. First, we start with one table. One table, 1 into 16. Next, we
4
take
fours are
two.
16.
Don't go to the highest number directly. John, John, John.
Yes, sir. Yes, sir. Yes, sir.
Don't jump into the bigger number directly. Step by step. After second class, you have to go to third class. After third class, you have to go to fourth class. Yes or no? Will you jump into the 10th class directly?
No, sir.
No, sir.
So here also we follow the same rule. Here first class is over, means first table is over. After second class, we have to take second class, means second table. How many times it goes? To 8 times. Now third class, will it goes?
No,
Three,
sir.
four. So leave that class. We don't like it. Now take the fourth class. What is the fourth?
4 fours are 16, sir.
Yes, 4 fours are 16. After that, we stop here. Why we are stopping here? See, second number is also 4. Second number is also 4. Here, in this case, the second number is 5. So, After second class, we had to check third class. Can you get 10 in the third class? Means in the third table, can you get 10?
No,
Can you
sir.
get 10?
No, sir.
No. Can you get 10 in fourth class? Means in the fourth
No,
table,
sir.
can you get?
No, sir.
Next, after fourth class, what is the next class? Fifth class.
Fifth
Yes or
class.
no? So already here, fifth class is already there. Already fifth class is there. So we have stopped by these two steps. We stopped by these two steps. Understood? We had to study the classes, first class, after that second class, after that third class, after that fourth class. Please remember, class means table, first table, after that second table, two table, after that three table. If it is not possible in that table, this given number is not there, leave that table, leave that table. Next, take the next class, next table, that is fourth table. After this, we stop this process because we had to check the second number also. We had to check the second number, fourth class. So we stop this one. So what are the factors? 1, 2, 4. From top to bottom, we write the first numbers. From bottom to top, in the reverse order. Okay. From bottom to top, 4, already 4 we have written, 4, 8, 16. So these are the factors of 10, these are the factors of 16. Let us find common factors. Common factors of 10 and 16. Common factors of 10 and 16. Tell me what are the common factors of 10 and 16? 1. Okay. Round up.
1,
2.
2.
Yes or no? Only these two numbers are common factors. We have found the common factors. Out of these two numbers, which is the highest number?
2, sir.
So
2, sir.
HCF, the greatest number, highest number is the HCF of 10, 16. In the division method also, we got the same. Yes or no? We got here. See this example. We got the same number or not in the division method? Say yes or no.
Yes, sir.
Yes. Now, I will explain third method. That is,
Sir,
yes.
what
Benjamin?
will we do if the HCF we have to find like 2, 4, 6 and 2, 5, 7? We cannot do division method, right?
Sorry, Benjamin.
Yes, sir.
What's your doubt?
Sir, when we have to find the HCFs like 2, 4, 6 and 2, 5, 7, we cannot do the like a division method, no?
You can use division method. I will tell you. I will tell you. If more than two numbers are also given, if more than two numbers, then also I will explain. Just to, for example, I have taken only two numbers. I will extend this concept for finding HCF of three numbers, for finding HCF of four numbers. Like this, we can extend the concept. Okay.
Okay, sir.
This is called prime factorization method. The third method is called prime factorization method. Find HCF 10, 16. For the same two numbers, I am explaining third method. So in this method, we have to write each and every number as a product of prime numbers. Means like LCM, 2 5 times, 5 1 time. Okay. So 10 is equal to 2 into 5. Similarly, we have to write 16 as a product of prime numbers. Just like LCM, 2 8 times, 2 4 times, 2 2 times, 2 1 time. So 16 is equal to 2 into 2 into 2 into 2. Okay. So round of the common factors. So only one. Okay. Therefore HCF of 10 comma 16 is 2. This is another method. This is called prime factorization method. These are the three methods commonly we use to find HCF of given numbers. Out of all these three methods, division method is little bit easier. That is why I gave preference. I gave priority to this method. First method, that is division method. Okay, these are little bit lengthy methods. Suppose if big number is given, suppose 100. Okay, here suppose here 450 is given. How to find HCF of given numbers? It is a little bit difficult to write the factors of 100. We have to write factors of 450. Okay, little bit lengthy process. That is why I prefer to follow division method. But you should know these methods also. I have taken this topic because when you are getting a fraction, to write a fraction in its simplest form, in its lowest terms, this concept is very useful. HCF, suppose 10 by 16 is given. Suppose 10 by 16, 10 by 16, not 16 by 10. To write this fraction in its simplest form, we have to divide the numerator and denominator by HCF of these two numbers. What is the HCF of these two numbers?
2, sir.
So we have to divide numerator by 2 and the denominator by 2. Then what will you get to 16 by 2? 8. Yes or no? 2 8 times. 2
5 times.
5 times. So this fraction is said to be in the lowest terms. This fraction is in its how do you say the fraction is in its lowest terms? If you find HCF of these two numbers, if you get 1 as HCF of the numerator and denominator, then we say that fraction is said to be in its lowest terms. Now let us find the HCF of 8 and 5. Let us find
Yes, sir.
HCF of 5 and 8. Okay, I use here division method. So we divide the bigger number by smaller number. So here bigger number is 8. So we are dividing this number 8 by the smaller number 5. How many times 5 table goes in
1,
8?
sir.
5 1 times. What is the remainder here?
3, sir.
Then what should be done here?
5, sir.
We have to take this
Yeah,
remainder
sir. We have to take division.
as a new divisor, and we have to take this previous divisor as a dividend. Okay, how many times 3 goes
3
in?
1, sir.
Yes, 3 ones 3. What is the remainder here?
2, sir.
So we have to take this remainder as new divisor. What is the previous divisor?
3, sir.
3, sir.
So divide this previous divisor by this new divisor. How many times 2 table goes in 3?
1, sir.
1 times 2. What is the remainder here?
1, sir.
So we take this remainder as a new divisor. What is the previous divisor?
Sir.
2. Divide this previous divisor by the new divisor. How many times 1 table goes in number 2?
2.
2 times. What is the remainder here?
0.
0.
So what is the last divisor in this long process?
1, sir.
So here HCF of 5 and 8 is equal to 1. What you got here, HCF of these two numbers 5 and 8? 1. That is why this fraction 8 by 5 is said to be in its lowest terms.
Sir, before you did the division, how could you find that that was in the lowest term?
Before?
So before you did the HCF of 5 and 8,
Uh,
how did you tell that this fraction is its lowest terms?
actually, this is not in its lowest terms. This
Okay,
fraction
sir.
is not in its lowest terms. Can you say why this fraction is not in the lowest terms? Can you tell me? Can you tell me the reason why this fraction is not said to be
So
in its
because we did not get 1 when we...
HCF of these two numbers? HCF of these two numbers. What is the HCF of 16 and 10?
2, sir.
So that is why we are telling that this fraction not in its lowest terms. Whereas if you take this fraction, if you find HCF of numerator and denominator, we got 1. That is why we say that this fraction is in its lowest terms.
Oh, okay, sir.
Understood this point, my dear John?
Yes, sir.
Yes. So in this context, means when you are interested to write a fraction in its simplest form, this concept HCF of numerator and denominator is a very useful concept. After finding HCF of numerator and denominator, so see here, see this step, I divided the numerator and denominator by HCF of 16 and 10. Previously, we found HCF of 16 and 10. What is the HCF of 16 and 10?
2, sir.
So that is why if you divide the numerator and denominator by the HCF of the given numerator and denominator, automatically after simplification, automatically we get a fraction. This fraction, the final fraction, is said to be in its lowest terms.
Okay, sir. Sir, if we can divide any number, like once after we divided with the fact of the HCF of 2, sir. Sir.
Here, HCF of these two numbers is 2.
Yeah, sir.
I will take another example. I will tell you another example. Not every time by 2. First we had to find HCF of
Yeah, sir.
numerator.
Yeah, sir.
Not every time we should not divide the numerator and denominator by 2 every time. I will tell you another example.
So one doubt.
Yes.
Sir, once after we got 8 by 5, sir,
Uh,
we cannot divide it, no, sir. So if we get any even number, can we bring it to the lowest form again?
Here even number or odd number, it is not a matter. It doesn't matter. Whether it is even number or odd number, it doesn't matter. If you find HCF of numerator and denominator, that is the main concept. It may
Okay, sir.
be even number, it may be a composite number, it may be a odd number, it may be prime number. It doesn't matter.
Okay, sir.
about that concepts. Don't deviate from this concept. It may be even number, it may be an odd number. These numbers may be even numbers or odd numbers, whatever the numbers it may be. Leave that concept. Don't deviate from this concept. So, if you write this fraction in its lowest terms? Still 8 by 5. I gave 8 by 5. Can you write it again in its lowest terms? Tell me.
No, sir.
Uh, and this concept, HCF concept, will be helpful in finding whether the given fraction is in its lowest terms or not. Whether the given fraction is in its lowest terms or not. I will tell you one example.
Sir, can you show us? Thank you,
Okay.
sir.
Can you say this fraction in its lowest terms? Why?
Because we don't know the HCF.
Yes. First of all, we had to check the HCF. We had to find the HCF of these two numbers. I use here only division method. Do you think any other method is easier method? Tell me. Factorization method or factors method. This is common factors method. This is the prime factorization method. Which method?
Division?
In my opinion, in my experience, division method is the easiest method to find HCF. Okay, so let us find HCF of 77, 143. So here smaller number is 77 and bigger number is 143. How many times it goes? Tell me. How many times is
Sir,
77?
2.
Multiply 77 table, prepare 77 table in rough work. 77 ones are 77, 77 twos are 154. Okay,
Sir, 1, sir.
only one time. Then what is the remainder? Tell me. Tell me the remainder here.
Fi-
Take
6,
pen
sir.
and take pen and paper and tell me the answer. Take pen and paper, my children, and tell me. Subtract 77 from 143 and tell me the remainder.
6, sir.
66, sir.
Huh?
66.
66?
Minus 66, sir.
Huh? Is it right
Minus
or wrong? Huh?
Sir, 66 is the answer.
Okay, 66. So, remainder is 66. What is the previous divisor?
77, sir.
77. Divide this 77 by this new divisor. How many times it goes?
1, sir.
One time. Tell me the remainder. Take pen and paper and
11,
do
sir.
11. So, what is the previous divisor?
66, sir.
How many times 11 table goes?
6,
6,
sir.
sir.
6 times. Then can you tell me what is HCF
11,
of
sir.
11, sir. 11.
the last divisor is 11.
11, sir.
So here we got HCF of these two numbers is 11. Therefore, we can say that this fraction is not in its lowest terms.
Yes,
Then
sir.
how do you write in its lowest terms? What is the
By
step to?
dividing with 11.
Yes, very good. Very good, my dear John. 143 by 77. This is not in its lowest terms. To convert, to write this fraction in its lowest terms, we have to divide this numerator and denominator by their HCF. What is HCF? We found here 11. So 143 divided by 11 by 77 divided by 11. Now divide 143 in rough work. In rough work, divide 143 by 11. Tell me the quotient. What is the quotient? Tell me. Take pen and paper and tell me the
Sir,
quotient.
13 by 7.
Yes, 13. 13. Yes or no?
Yes, sir.
11, 11 ones are 11. Here 3 will be left. We have to bring down this 3. 11 threes are 33. So 11 table, how many times it goes in 143? 13 times. So 7, 17, 7.
7,
How
sir.
many times? 7. Now this 13 by 7, this fraction is said to be in its lowest terms. After dividing the numerator and denominator by their HCF, automatically it converts it converts into its lowest terms. Understood this point, my dear children?
Yes, sir.
This is the advantage. This is the advantage of HCF. Actually, I think to simplify this number, you may use factorization method, I think. How do you write a fraction in its simplest form? Which method you follow? Generally, which method you are following? Suppose if this fraction is given, then which method you follow previously? Now,
Division, sir.
how do you divide? Will you divide 143 by 77?
No, sir.
I'm asking here. In the previous class, with your previous knowledge, in previous classes, how do you write this fraction in its simplest form, in its lowest terms? Which method you followed?
Prime factorization, sir.
Yes, prime factorization method. But it may be very difficult. It may be difficult for some students. It is some difficult for students for writing numerator as prime factorization and denominator also as prime factorization. We have to write prime factorization for numerator as well as we have to write prime factorization for denominator. It seems little bit difficult, but if you follow this procedure, we can easily find out HCF of numerator and denominator. Then we can divide the numerator and denominator by easily by this HCF. We can get remainder 0. Automatically we get remainder 0. That is the advantage. That is a plus point of HCF. Okay, my children, understood this point?
Yes, sir.
Advantage of HCF. This HCF concept is very useful in writing a fraction in its lowest terms. Especially in this case, we can use HCF, the concept of HCF. Okay, my dear children.
Yes, sir.
Yes, my dear John.
Yeah, sir. Thank you, sir.
Write this fraction in its simplest form. Write this fraction in its lowest terms. Take pen and paper, my dear
Can you
children.
give us time?
Ah, yes, yes. I will give time for you. I will
Okay,
give
sir.
time for you. All of you, my dear children, take a pen and paper. Take a pen and paper and write this fraction in its lowest terms and show me. After writing this fraction in its lowest terms, show me your answer. Okay. Are you writing the given fraction in its lowest terms, my dear children?
Yes, sir.
Ah, yes. Do it now. Take pen and paper and
Sir,
write.
21 by 11.
Very good. How did you get 21 by 11?
Sir, by using the division method.
Which division method you used? First, what you found? What did you find first?
Sir, I found out the HCF of 44. Sorry, sir, 84 by 44.
Yes, 84 and 44. For these two numbers, first you found HCF of these two numbers. You got 4. Yes or no?
Yes, yes, sir.
So you divided the numerator and denominator by 4. Then you got here 21 by 11.
Yes, sir.
If you try to write this fraction in its lowest terms, you can't write. This is only the lowest
Lowest
term.
form.
Okay, my children, understood this point. This is the advantage of HCF. Okay, my children. What about other
Yes,
children?
sir.
Only John, only John found HCF of the numerator and denominator. What about other children?
Sir, found, sir.
Okay, my dear children. Now the time is 4 past 17 minutes. Now you can leave the meeting. Now you can leave the meeting, my dear children. Take
Thank you,
rest.
sir. Bye, sir.
Care of your health, my dear children. Stay at home. Stay safe. Sanitize your hands frequently. Maintain social distance of 2 meters from others. And do your work sincerely and seriously. Thank you, my dear children. Thank you all.
Thank you, sir.
Thank you, my dear John. Thank you, my dear Lavani.
Sir, are you from Andhra?
Yeah.
Okay, sir.
Why your doubt?
No, sir. Actually, even I am from Andhra.
Where are you from? Andhra? Which place?
Sir, Rajmandri, sir.
Oh, you belongs to Rajamundry.
Yes, sir.
Who are there in Rajamundry?
My grandparents, sir, they were staying there. They went to Kakinada.
Okay, okay. But then if school reopens, where do you stay here?
No, sir, I am staying actually in Karna. My parents, my native is Andhra.
Okay, okay. You are staying in Karinya, Karinya
Yes,
Nagar.
sir, Angel Garden.
Angel Gardens. What is your parents?
Sir, they are assistant professor in mechanical engineering, sir.
Okay,
Karnia.
okay. Both
Yeah, sir, mom and dad.
mom and dad. Okay, very good, my dear John.
Okay, sir. Thank you, sir.
Thank you, my dear John. What, Abhinay? Still you are online? Jeffrey, you are also stayed back online. Where you stayed back? Why did you stay back online? Jeffrey, 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 why did you stay back? You are not responding. I'm removing. Abhinay, you also not responding.